All right, hi there. So what you're looking at is the examples that we did in class over operations with polynomials. You can find this PDF on Schoology, and I linked it to the absent work outline. Okay, so if you're unable to print it, you could always just get out a piece of paper and copy the problems down because really they're not too lengthy. So what we're going to do is we're just going to go over different operations and just see different kinds of ACT and SAT problems that use operations with polynomials. So the reason for this video going over example 1 is this problem, if we were just to take every term and distribute it out, it would end up being a ton of work. And a lot of times it's very easy to make mistakes. So I have a clever little trick that I want to show you that you can do when you see that you've got, you know, one big polynomial multiplied by another big polynomial. So here's what we're going to do. We're going to distribute, and I'm going to start by taking 3x cubed times x squared and get 3x to the fifth, and then 3x cubed times negative 2x is negative 6x to the fourth, and then I've got plus 3x to the third. All right, so that seems pretty routine. Now, what I'm going to do next is I'm going to distribute the 5x squared. So rather than putting it over here and having a big long line of horizontal terms, what we're going to do is we're going to organize this a little bit more vertically. So I'm going to get 5x to the fourth, and I'm going to put that underneath the other x to the fourth term. And then I have 5x squared times negative 2x is going to be negative 10x to the third, and 5x squared times 1 is plus 5x squared. So can you see what I'm doing with this is I'm stacking it a little bit more vertically than rather than just doing the traditional, lining all the terms up in a big long row. All right, so now we've got negative 4x times x squared. So I'm going to put this negative 4x to the third, and then negative 4x times negative 2x is plus 8x squared, and finally negative 4x times 1 is negative 4x. So we have one more distribution. We need to take the 6, and we're going to get 6x squared, and that 6x squared right here is going to go right under the other x squared terms, and then 6 times negative 2x is negative 12x, and 6 times 1 is plus 6. So finally now, when I think about adding all these terms up, I really just need to go down the columns. And so this is going to be 3x to the fifth, and then I add down, right, and I get negative 1x to the fourth, and this, let's see, negative 14 plus 3 is going to make negative 11x to the third. 5 plus 8 plus 6 is going to make plus 19x squared minus 16x plus 6. And like I said, it's just a different way to organize it, but it's a really clever way to multiply bigger polynomials without it ever getting too messy, and it minimizes mistakes. Okay, so what I want you to do for the rest of this video is I want you to hit the pause key, and I want you to do 2, 3, and 4 on your own. Okay, that's what we did in class. Students work through these on their own. So I want you to work through examples 2, 3, and 4 on your own, and then when you're ready, I want you to hit the play key. You can watch me work it out and see if you got the same answer. Okay, and you can use this video for what you need. So if you want to fast forward through my work and just see if you got the answer right, great. If you realize you missed it, you can rewind and see how I did the work, and you can find your mistake. Okay, so hit the pause key, work on the next 3 examples, join me when you're ready. All right, so what we're going to do for this example is we are going to pretty much distribute, okay, anything that I see. So we've got negative 12 x squared y. This is going to distribute to make, sorry about that, let's see, plus 6 x cubed y squared, and then finally we've got a plus 9 squared y. So the purpose for this example is understanding that polynomials can have more than one variable, but the key is that all the variables are whole numbers. So let's see if we can identify what would be like terms. Like terms have the exact same variables to the exact same powers. So this 4x squared y would combine with this negative 12x squared y, which would combine with the 9x squared y. And when I combine those, and I get 4 and negative 12 is negative 8, negative 8 plus 9, it's going to make 1x squared y. Okay? And then in a similar fashion, if I see this x cubed y squared is going to combine with this 6x cubed y squared, and it's going to combine to make 13 x cubed y squared. Okay, now I'm okay with you putting it in this order. I'm fine with you leaving it as this answer, but sometimes what you're going to see is you're going to see that they're going to pick a variable and they're going to write that variable in decreasing order. So let's suppose we do that in terms of x. So sometimes what you'll see is maybe the x cubed comes first, and then we see x squared y, just so that the variables are written in decreasing order. But honestly, it's okay too, just to leave it like this. There's nothing wrong with that. All right, so the next problem is going to be another big distributing problem. So let's go through, and I'm going to distribute the x squared minus 3x plus 4ix. Okay, and then I'm going to distribute the negative 3. And we're going to get negative 3x plus 9 minus 12i. And you could try using a similar technique as I did in example 1. I tried to use that, and when I first did it, I kind of found that there weren't quite as many like terms. So I'm just going to do it this way and you know, kind of distribute them out. Negative 4ix plus 12i. Now here's where we got to be careful. This is where the mistake comes. It's when we take negative 4i times 4i is negative 16, but we can't forget the I squared. All right, so let's go through and let's start combining like terms. And what I notice here is I see that this positive 4ix and this negative 4ix are going to cancel out. And in a similar way, negative 12i and positive 12i are going to cancel out. So let's just take a second and see what we have left over if these, and these all cancel out. Okay, so what I also see here, what I also see is that I do have this negative 3x and this negative 3x. So you know what, I'm going to combine that to make negative 6x. And then I see a plus 9, and then I see this negative 16i squared. Let's talk about this negative 16i squared. Let's recall that I squared is equal to negative 1. So this is really minus 16 times negative 1. So when I write this out, it's going to make x squared minus 6x plus 9 plus 16, making our final equation plus 25 for the constant term. Okay, so what we ended up with was this quadratic trinomial when we multiplied all of this out. Okay, all right, so for the last one, this was a practice SAT question. I like it, it's clever, because you go in and you're not quite sure how you're going to end up with this a squared plus b squared, but you almost just have to go in and you just have to, you know, kind of do the algebra and just see where it takes you. So when I see a minus b squared and a plus b squared, that tells me that I'm going to double distribute. Let's see what happens. So when I double distribute, I get a squared minus 2ab plus b squared. That's the result of double distributing. When I double distribute here, we get a squared plus 2ab plus b squared. All right, so let's just see what's going on. So when I look at this, I see that there is a negative 2ab and a positive 2ab that are going to combine. And then I also see that an a squared and an a squared can combine. And finally, I see that b squared and b squared. Okay, so we've got all these like terms. Let's see what happens. A squared and a squared makes 2a squared. Negative 2ab and positive 2ab are going to equal 0. And then b squared plus b squared makes 2b squared. So just like that, we start seeing, okay, now I'm starting to see how we're going to get that a squared plus b squared. So what we're going to do is we're going to divide by 2. And when you divide by 2, you just need to make sure you're dividing both of them by 2. And what happens is we get a squared plus b squared is equal to 12. So what does a squared plus b squared equal? It equals 12. All right, so there's going to be an assignment that goes along with this. I've linked it to the absent work outline. And hope all this made sense. See you soon.